In Chapter 3, we'll be working with the rules for exponents, and then we'll also get into scientific notation. So starting with the product rule. So the product rule for exponents is as follows: b to the m, so base b to the mth power, times the same base to the nth power, means we can combine them into one base by adding the exponents. So let's kind of see why this is. So let's say we had b squared times b cubed. That means it would be b times b for the b squared, and then b cubed would be b times b times b. This equals b to the fifth, right? There's 5 b's being multiplied, which is exactly what our rule told us. It means if we're multiplying b squared times b cubed, we add them, b to the 2 plus 3, which is b to the fifth. So let's do some examples using this rule. So let's multiply each expression. So for the first one, we have 2 squared times 2 cubed. So this rule tells us that if we have the same bases, which we do, we can add their exponents. So add the 2 plus 3, and we get 2 to the fifth. Next one, we have x cubed times x. So anytime an exponent is not written, we know there's an exponent of 1 there. So this is going to be the same thing as x cubed plus 1, x to the 3 plus 1, which is x to the fourth. Okay, next one gets a little messier here. We have multiple variables. So we have 6x to the fourth y cubed times 5x squared y to the seventh. So what we're going to do is we're going to multiply the constants together. 6 times 5 is 30. Then the x's, x to the fourth times x squared will be x to the 4 plus 2, times the y term, y to the third times y to the seventh. That's y to the 3 plus 7. So simplifying that, that's going to give us 30x to the sixth, y to the 10th. And last one here, negative 2x squared z cubed, xy squared z cubed, 4x to the fourth, z to the 16th, y to the 8th. So multiply the constants, so negative 2 times 4 is negative 8. Then we have multiplying the x's. X with no exponent is x to the first times x to the fourth, so x to the 1 plus the 4. The y terms, y squared times y to the 8th. So it's out of order for the second one, but that's okay. You just got to make sure you don't mess up. So that's y to the 2 plus 8. And then the z term is going to be z to the 3 plus 16. Okay, and then just simplifying this, adding those exponents. That's negative 8 x to the fifth, y to the 10th, z to the 19th. Okay, so that's the product rule. So the next thing is going to be the quotient rule. So it's pretty similar. When we were multiplying common bases, we add the exponents. When we divide common bases, we subtract the exponents. So if we have b to the m over b to the n, combine it into one base, which would be b to the m minus n. So whatever is in the denominator is a negative, is getting subtracted. So let's see why that is. So let's say we have b to the fifth over b cubed. Based on this rule, we know that the answer should be b to the second, because b to the 5 minus 3. B to the fifth is b multiplied together 5 times. B cubed is b times b times b. So what we can see here is that 3 b's will cancel in the numerator and denominator. We'll be left with b times b, which is b squared. Okay, so that tells us that b to the fifth over b cubed equals b to the 5 minus 3, which is b squared. So let's go ahead and use this rule in some examples here. So the first one, we have x to the 6th divided by x squared. Okay, so same base and they're being divided. So we're going to subtract numerator's exponent minus denominator's exponent, so x to the 6 minus 2, which is x to the 4th. Okay, and then for the next one, we have 2 to the 7th divided by 2 to the 4th. Same base of 2, we can combine them. That's going to be 2 to the 7 minus 4, so numerator's exponent minus denominators, which is 2 cubed, which we could simplify to 8 if we really wanted to. I'm just going to leave it like this for now. Next one, negative 3 to the 6th divided by negative 3 squared. So the fact that it's negative does not matter. Same thing, just keep those parentheses. That's negative 3 to the 6 minus 2, which is negative 3 to the 4th. And for D here, we have a little bit more complicated one. 30x to the 12th, y to the 9th, divided by 5x cubed, y to the 7th. So we go term by term. So 30 divided by 5 is 6. X to the 12th divided by x cubed, that's x to the 12 minus 3. And then y to the 9th divided by y to the 7th, that's y to the 9 minus 7. So simplifying this, 6x to the 9th times y squared. So that was so far the product and quotient rule. For the next one, we have zeros as an exponent, which I believe we've already seen. So we know that anything raised to the 0 power equals 1. Let's kind of use some of these rules just to get an idea of why. Let's say we have b to the 4th. Oops. B to the 4th divided by b to the 4th. We know that this equals 1, right? Because they cancel each other out. Or what we could have said is b to the 4th over b to the 4th, based on the quotient rule, is b to the 4 minus 4, subtracting the exponents, which is b to the 0. So in both of these, we started with b to the 4th over b to the 4th. The first one, we got 1. Second one, we got b to the 0. So this means that b to the 0 has to equal 1, because b to the 4 over b to the 4 equals 1 and b to the 0. So let's do some examples real quick here. So we have 8 to the 0 power. So that's pretty easy. That's just equal to 1. Anything to the 0 is 1. Next one, negative 6 to the 0 power. Once again, it's equal to 1. The whole thing is being raised to the 0, so it's 1. Next one, 5x to the 0. Once again, the whole thing's being raised to the 0, so it's 1. Next one, negative 4 to the 0. So this time, this is based on order of operations. This is negative and then 4 to the 0, which is going to give us negative 1. So parentheses definitely matter a lot. Next one, 3y to the 0. That exponent is only on the y. So this is 3 times y to the 0, which is 3 times 1, which is just 3. The last one here, we have negative 3x squared times yz to the 0. The only thing raised to the 0 here is the yz. So that's just going to be times 1. So this whole thing is just negative 3x squared. Okay, so pretty much just have to be careful with parentheses. Okay, so far all of these exponents have been positive. So let's do some negative exponents. So for negative exponents, that's something like b to the negative n. What that does is it essentially reciprocates the number and raises it to the positive exponent. So b to the negative n equals 1 over b to the positive n. So let's get an idea of why. So b cubed over b to the 5th. We know that b cubed is b times b times b. B to the 5th is b times b times b times b times b. So these are going to cancel. 3 of these are going to cancel. We're going to be left with 1 over b times b, which is 1 over b squared. Or, based on the quotient rule, if we subtract the exponents, b to the 3 minus 5, we know this equals b to the negative 2. So kind of just like the other one that we just did, we started with b to the third over b to the fifth for both of these. The first one we ended up with 1 over b squared. The second one we ended up with b to the negative 2. So we know that they have to be equal. So b to the negative 2 equals 1 over b squared. Okay, so let's do some examples. So let's write all of these expressions that have negative exponents with positive ones using that rule. So 9 to the negative 2, that's 1 over 9 to the positive 2. So don't make the mistake of negating the number. That's a pretty common mistake, so just don't do that. So negative 2 for b here, negative 2 to the negative 5. That's going to be 1 over negative 2 to the positive 5. For c, we have 1 over 6 to the negative 2. So what we could do is we can rewrite this as 1 over 1 divided by 6 to the positive 2. And then you'd have to divide fractions, change it to multiplication. Or we can just realize anytime something is in the denominator with a negative exponent, we can plop it up in the numerator and give it a positive exponent. So 1 over 6 to the negative 2 equals 6 to the positive 2, so 36. Last one here, we have 7x to the negative 5, y squared. So we want to rewrite this with positive exponents. So the 7 is fine. The y squared is fine. Instead of x to the negative 5 in the numerator, we can have x to the positive 5 in the denominator. Okay, so a couple more rules here, I think. So the next one is the power rule. We got about 2 more. So the power rule is going to be when a term that already has an exponent is raised to another exponent. So essentially it's power to a power. So if we have b to the m and then raised to the nth, what that means is we multiply exponents. So it'd be b to the m times n. So what I like to say here is a power, if you have a power raised to a power, you multiply them. So for example, let's see y. So let's say we have b squared and then cubed. So if we were to expand this, this would be b squared 3 times, right? Based on the first rule, the product rule, this would be b raised up to the 2 plus 2 plus 2, adding all the exponents, which is b to the 6th. So if you take a look at that, you can see that what we did to get b to the 6th, a shortcut way would just be multiply the 2 times 3. So that means b to the 2 and then to the 3rd is b to the 2 times 3, which is b to the 6th. So don't get this confused with the product rule. So let's do some examples. So we have x cubed and then to the 9th. So it's a power to a power, so we're multiplying. That's going to be x to the 3 times 9, which is x to the 27th. Next one, 2 squared to the 3rd. Power to a power, we multiply. That's 2 to the 2 times 3. 2 to the 6th. Next one, y to the 5th to the negative 3. That's going to be y, oops. So we have to multiply. So y to the 5 times negative 3, which is y to the negative 15. And I'm going to go one step further and use that rule from the previous page. Rewrite this with a positive exponent. That's 1 over y to the positive 15. Last one here, we have b to the negative 4, then to the negative 2. So that's power to a power. That's b to the negative 4 times negative 2. Negative 4 times negative 2 is positive 8. So that's b to the 8th. Okay, next rule before we get into maybe 2 more rules. The next one is the product to powers rule. So if we have something like a times b, so something times something, and it's all raised to the nth power, we can split that up and give both of those factors the exponent of n. So a times b all to the nth is going to equal a to the nth times b to the nth. So let's get an idea of y again. So let's say we have 2x cubed. We know that this is 2x times 2x times 2x. We can rearrange this thanks to our commutative and associative properties. 2 times 2 times 2 times x times x times x, which we can see is now 2 cubed times x cubed. So that means the shortcut way, obviously, is 2x cubed just equals 2 cubed times x cubed. And there obviously can be more than just two factors in there. So let's simplify using that rule. So we have 3y to the second. So that's going to be, based on this rule, it's going to be 3 to the second times y to the second. We give both of those factors the exponent. So that's going to be 9y squared. Next one, negative 2y to the y squared all to the fourth. So we need to give both of these factors an exponent of 4, so negative 2 to the fourth times y squared to the fourth. So a little bit more complicated here. Negative 2 to the fourth, so it's a negative to an even power, so it's going to be positive. 2 to the fourth is 16. And then y squared to the fourth, that's going to be the power to a power rule, so we have to multiply. 2 times 4 is 8. So 16y to the 8th. And a little bit more complicated, 2 times negative 3x z to the negative 1 cubed. So I'm going to give each one of those terms inside each one of those factors inside the parentheses an exponent of 3. So we get this. So negative 3 cubed, so 2, negative 3 cubed is going to be negative 27. And then that's just going to be x cubed. Z to the negative 1, and then to the third is going to be power to a power. We multiply. Negative 1 times 3 is negative 3. So let's finish simplifying this. 2 times negative 27 is negative 54 times x cubed. Rewriting the z to the negative 3 with a positive exponent, so throw it in the denominator with a positive exponent. Lastly here, we have negative and then x squared y cubed z all to the negative 5. So the negative stays out front. Each one of these terms get an exponent of negative 5. So we get this. And these are all powers to powers, so we're going to be multiplying. So negative, and then x to the 2 times negative 5, that's negative 10. For the y term, we have 3 times negative 5, negative 15. And the z is z to the negative 5. So we're rewriting all of these with positive exponents. They're all going to be going in the denominator. So we're just left with a 1 in the numerator. So that's going to be negative 1 over x to the 10th, y to the 15th, z to the 5th. Okay, so next one, quotient to powers rule. So now this is the last rule here. So if we have, it's really similar to the one that we just did. So if we have a fraction, so two things being divided, a divided by b, and the whole thing is raised to an exponent of n, we can give the exponent to the numerator and denominator. So I'm going to skip kind of showing why that is for this one. Let's get into using it in the examples. So for the first one, we have 2 over x to the 4th. So a fraction to an exponent, we're going to give the numerator the exponent as well as the denominator. So we get 2 to the 4th over x to the 4th, and I'll just write that as 16 over x to the 4th. Next one, we have negative and then 2 over y to the second. So what I'm going to do, that negative out front, I'm going to use that with the numerator. So I'm going to give that exponent of 2 to the numerator and denominator. Negative 2 squared is positive 4, so this is 4 over y squared. Next one, x squared over 4 all cubed. So once again, give the numerator the exponent, give the denominator the exponent. So x squared cubed, that's a power to a power. We multiply. 2 times 3 is 6. 4 to the third is 64. And the last one for this one, we have a negative exponent. So what I'm going to do, when you have a negative exponent, a couple different ways you can think about it. The easiest way is going to be reciprocate what's inside of those parentheses, make the exponent positive. So instead of 2x over yz cubed, it's going to be yz cubed over 2x. And then it's going to be raised to the positive 6. Essentially, we're just using the fact that anything raised to the negative 1 means it's reciprocal. Okay, and now I'm going to use that same property. So let's give the numerator that exponent and the denominator. So in the numerator, we need to give both of those factors the exponent. So that's going to be y to the 6th times z cubed to the 6th. It's going to be a power to a power. We multiply and we get 18. Denominator is going to be 2 to the 6th times x to the 6th. So our final answer here is y to the 6th times z to the 18. 2 to the 6th is 64 times x to the 6th. So as long as you go one step at a time, it shouldn't be too bad. So now we're going to get into simplifying exponential expressions and what it means to be completely simplified, and we'll do a bunch of examples. Okay, so for simplifying, what it means is that it is simplified when there are no more parentheses and when no powers are raised to other powers. Each base is only there once, and we have no negative or zero exponents. So let's do these examples. So we have negative 3x to the 4th, y to the 5th, all to the 3rd. So all of these factors need to be raised to the 3rd power. So we get this. Negative 3 to the 3rd is negative 27. X to the 4th to the 3rd, power to a power, we multiply, get 12. Y to the 5th to the 3rd, power to a power, multiply, we get 15. Okay, and then for the next one, negative 7 times x, y to the 4th, times negative 2, x to the 5th, y to the 6th. So we're going to multiply the constants. Negative 7 times negative 2 is positive 14. X to the 1st times x to the 5th. Remember, that's an exponent of 1 if it's not there. So we have to add them. This is the product rule. That's x to the 1 plus 5 times y to the 4 plus 6. So we get 14x to the 6th, y to the 10th. Oops. Okay, next one. We have a big fraction here, negative 35x squared, y to the 4th, divided by 5x to the 6th, y to the negative 8. So negative 35 over 5 is negative 7. So this is going to be that quotient rule, so we have to subtract the exponents. It's going to be x to the 2 minus 6th and y to the 4 minus negative 8. So when you're using that quotient rule and you're subtracting the exponents, it's always, everything's in the numerator now. So negative 7, x to the negative 4. 4 minus negative 8 is 4 plus 8, so that's to the 12th. Okay, so we have to rewrite this with positive exponents only. So that's negative 7 y to the 12th over x to the 4th. Next one, 4x squared over y to the negative 3. Once again, the whole entire thing is raised to a negative, so let's just reciprocate it right away. So it becomes y over 4x squared to the positive 3. We give the numerator the exponent as well as the denominator. In the denominator, we have to give both of those factors the exponent, so that's 4 cubed times x. So x squared to the third power to a power, we multiply and get 6. So simplifying this, that's going to be y cubed over 4 cubed is 64. So that's our final answer. Okay, so we'll do 2 more of these ones. As you can see, they get pretty messy. So we have negative x y to the 4th squared times x cubed y z to the negative 2 cubed all over 2x to the 6 y to the negative 8 z to the negative 1 to the 4th. Okay, so for these ones, deal with the numerator and denominator separately, and then we'll combine them when they're both simplified individually. So for this first big factor up here, I'm going to give everything a power of 2, including that negative 1. So negative 1 squared times x squared times y to the 4th, x squared squared, times y to the 4th squared. Okay, and then the next term, the next factor here, we have x cubed, and then we're going to give every factor an exponent of 3. So it's x cubed to the 3rd times y cubed times z to the negative 2 cubed. That denominator, give every term an exponent of 4, so it's going to be 2 to the 4th times x to the 6th to the 4th times y to the negative 8 to the 4th and z to the negative 1 to the 4th. So pretty messy, but just stick with that numerator. So I'm going to do this in one step for room's sake here on this page. So negative 1 squared is actually just positive 1, so that term simplifies to 1, so we don't have to write it. X squared squared is going to be x to the 4th, multiply, power to a power. Y to the 4th squared is y to the 8th, times x cubed cubed is x to the 9th, times y cubed. Z to the negative 2 cubed is z to the negative 6. Okay, that denominator, 2 to the 4th is 16. X to the 6 to the 4th, that's x to the 24. Y to the negative 32, z to the negative 4. Okay, so 2 more steps here. So simplifying that numerator, we have x to the 4th times x to the 9th, we have to add it, that's x to the 13th. Y to the 8th times y cubed, add it, that's y to the 11th, and z to the negative 6. And for that denominator, it's already done, so let's combine these using positive exponents in that quotient rule. So it's going to be 1 over 16. So the 16 is still in the denominator. It's going to be x to the 13 minus 24. Y raised up to the 11 minus a negative 32. Let me erase this so I have more room. Okay, y to the 11 minus a negative 32. And then that z term is z to the negative 6 minus a negative 4. So super messy and kind of ran out of room. So let's simplify this. So x to the 13 minus 24, I'm going to do it over here a little bit. 13 minus 24 is going to give us negative 11. Y to the 11 minus 32, that's 11 plus 32, so that's 43. Negative 6 minus negative 4, that's negative 6 plus 4, which is negative 2, all over that 16. So all you have to do is put that x and y and z term, x and z term in the denominator to make their exponents positive. So that's y to the 43rd over 16, x to the 11th, z squared. So really messy, but that's our answer. So for this next one, I'm not going to go through and do the whole thing, just for the sake of that one taking a while. What I will do is start it off, and then I'll write the answer down. Okay, so we have this whole nasty big fraction to the negative 2. So what I'm going to do to start it off is I'm going to rewrite this by reciprocating what's inside those big parentheses. So that big denominator becomes the numerator. And then the numerator becomes the new denominator. So the reason we did that was because now this is only raised to the positive 2. It's not raised to the negative 2, it's raised to the positive 2. So I'll say one more thing, and then maybe you guys can try it on your own. What I would do here is I would simplify everything inside of here first. I would leave everything raised to the second power. I wouldn't touch that until the end, and then I would simplify it. So if we did that, what we would end up getting is, we would end up getting 25, put a little dot, 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 so we know I skipped a million steps. 25 over 16, x to the 12th, y to the 22nd, z to the 10th. So obviously I encourage you to give that a try yourself. Just take it one step at a time, and it's really not that bad, just kind of time consuming. Okay, so that's it for that part, but for the last thing here, we have scientific notation. So kind of switching gears, but only just a very little bit. For scientific notation, I think we only have 2 pages. A number is in scientific notation. I'm sure we've seen this before. When it's expressed in this form, it's going to be a number a, where the absolute value of a is greater than or equal to 1 and less than 10. So it's like between 1 and 10. The absolute value is between 1 and 10. So it's written as that number times a power of 10, so times 10 to a power. And n is an integer here. So for example, if we have something like 2,300,000, that's the same thing as 2.3 times 10 to the 6th. So that's pretty much saying it's 2.3 times 1 million, which is 2.3 million. So it's scientific notation on the right, decimal notation on the left. So when we're converting between scientific notation or scientific notation to decimal notation, all this is going to be is essentially moving the decimal place. If the n, so if that exponent of n is positive, we move the decimal point to the right n places. If the n is negative, we move it to the left n places. So it's really as easy as that. So for example, let's write these in decimal notation. So 6.2 times 10 to the 7th. So what this is going to be is it's going to be 6.2. We have a positive 7, so that means we're moving it to the right because it's positive. So we're moving the decimal point to the right 7. We're going to put it right there. We need to fill in zeros here. So that is our answer. So our answer here is going to be, is that 62 million. So 6.2 times 10 to the 7th is essentially 6.2 times 10 million. So 62 million. So we can do this because we are in the decimal system, which is base 10, which just involves moving the decimal point over. Next one, negative 2.019 times 10 to the negative 3. So I'm going to ignore the negative for now. And I'm going to write 2.019. The exponent here is negative, so that means we're moving it to the left. 3. So 1, 2, 3. Placing it there. We need to fill in zeros. So our answer here is going to be 0.002019. Okay, so not too bad for those, hopefully. Oh, actually almost forgot that negative. So it's going to be negative 0.002019. Okay, so just ignore the negative for the actual movement of the decimal and then bring it in afterwards. So now we're going to be going the opposite way. We're going to be converting decimal notation to scientific notation. So in order to write it in scientific notation, we need to find what a and n is and write it in the form a times 10 to the n. The a is going to be found by moving the decimal point over until we find a number whose absolute value is between 1 and 10, including 1. And then we're going to determine what the exponent is by counting how many places the decimal point was moved. It's positive if the decimal point was moved to the left. It's negative if it was moved to the right. So let's do these examples. So we have, what is that, 34 billion 970 million. So what we're going to do is we're going to understand that the decimal point is at the end, and we're going to move it over and count as we go until we get a number between 1 and 10, absolute value between 1 and 10. So we get 3.497. So this is going to be 3.497 times 10. So we moved that to the left. So that means it's going to be positive. And we moved it over 10 places. So that's going to be our exponent. So 3.497 times 10 to the 10th. And you can obviously check by going in the reverse direction here. We would have to move that to the right 10 places. Next one, we have negative 970 million. So decimal point, once again, is over here. And we keep on moving it over until we get a number whose absolute value is between 1 and 10. So that's negative 9.7. So this is negative 9.7 times 10 to the, we moved it to the left. So it's going to be positive, and we moved it 8 spaces. So negative 9.7 times 10 to the 8th. And lastly here, we have this big decimal. So point, a whole bunch of zeros, and then a 2. So here's the decimal. So we're going to move this until we get to, I think I did that right, until we get to a number between 1 and 10. So 8.2 times 10 raised up to, we moved it to the right, so it's going to be negative, and we moved it 11 times. So that's 8.2 times 10 to the negative 11. Okay, and once again, you can check by starting with your answer and making sure it is what you started with when you put it back in decimal form. Okay, so that's it for section P3. A lot of rules for exponentials, or exponents rather, and we use those kind of in this scientific notation.